So we have seen what happens when we try to transfer data between two computers in a very simple way, with a very simple connection. Let's try a little bit more interesting. So there's an end device. Let's take a server. Let's put it here. PC1 always on top. Let's make it always on top, otherwise it creates trouble. Similarly, let's make this always on top. Okay, otherwise maybe we don't need it anyways. So this PC we had already configured with 10.1.1.1. But let's look at the GUI. You see, these all physical different components are there. Okay, then we have this configuration of the links. Then you have different applications in the PC and some other things are there, not important. If you go to the server, there is something else apart from the other things. You have this list of services. A server provides services. A Google server, for example, provides service. You can search the Google engine. Similarly, Amazon, Facebook, everybody, these are content delivery networks. They provide services. A server is, in a simple way, it's a very powerful computer with lots of memory and lots of processing power. So let's see what are the services available. For example, this in this fake or fake server that we have, or simulated server, it has provided this HTTP and HTTPS services. So if you are able to connect this PC to this server, then you should be able to see a web page using a web browser. There are then other things are there which is generally off. We can switch it on and provide those services. We have to configure them, but let's go with whatever is available. Email is there, for example. We have to set it up. Then we can access email also. But it's not set up at the moment, so we'll not go for it here. But there is another thing, FTP, file transfer protocol. So there are a bunch of fake files here or mock files here, and you can access them if you know the username and password. And you can copy these files to your PC from this server if you are able to properly connect to it. So we'll see one or two examples like this. Let's make a fake simulation or mock simulation of this. So we have config. Let's put them on the same network. So let's make it 2 because that was 1. PC was having 1 host number. Host address was 1. We'll put it in the same subnet. And let's see now. Let's connect it. So both the interfaces are up. So you should be able to connect. So let's do one attempt. This is a web browser in our PC. Let's put 10.1.1.2. What happens? We could not connect to it for some reason. Let's see why. Is there any mistake we have made? Okay. Now I understand. See, we did not put the in the wrong place. We 255.0, and here we have to do 10.1.1.2. Okay, so this is not the place to do it here. Okay, some error is happening. Let me see once again. 1.1.2, 255.255.0. Fine. Let's see. Yeah, it's up now. It's also up. So let's try to ping again on this PC. Let's try to access this web page that this server is hosting. We are now able to access it. Now, if you look here, let's see the services. HTTP. You see the things that are there. We're able to access all this HTML documents, this image and all that is hosted in this server through this web browser. Fine. So let's again check. We'll do one FTP. Let's try to do an FTP. Okay. So what will happen is this is FTP, and these are all these files there. Let's try to do an FTP. Okay. So by the way, when we first connected this again, when we did this web browsing, initially did not know the MAC address of the server and so on and so forth. Okay, so let's keep it on top. Let's keep it on top. So its MAC address is 825D. Its MAC address is A400. Okay, so initially did not know, so they had to do an ARP, and then the data was transferred. Means we were able to see the web page on this PC, exactly like we discussed for the previous case when we connected this PC with a laptop. So you can check here, for example, now the ARP table must have been populated. See, yes, so 825D has been populated. So before running this simulation, I deleted all the data that was before using this power cycle button. So here also you can, for example, check this is the command prompt ARP. So yes, both this server and the PC now has their ARP tables filled up. So anyhow, let's come here. We want to do an FTP. We want to access all these files. Okay, let's do FTP, file transfer protocol. So we want to transfer these files from this server to this laptop. Vice versa also we can do. But let's see this 10.1.1.2. It's asking for a username. We have to know this. So Cisco password, Cisco logged in. This command prompt has changed. Now we can see this. If I type this dir command, it lists all these files that is here. Okay, and now we can do a transfer. Let's say get. We want to copy this file to our PC, imaginary file. See, this link starts blinking. And it will go on. This blinking will stop as soon as this file transfer is finished. Now let's look at this. You can do simulate also for the web browsing application, but you can do it for this what do you call this FTP application also. Let's look at this FTP application once again. Okay, so we'll simulate Control C. You stop this in between. Okay, let's stop all this. Let's start simulation mode. Okay, and what we'll do is we will start a terminal. Sorry, command prompt. Again, we will do FTP 10.1.1.2. There is a packet formed. The packet is formed. You can have a look at it. It's a file transfer. It's a packet generated for file transfer. If you see in the OSI layer, this is the application layer, file transfer. It uses TCP in the network layer. TCP is a reliable connection-oriented protocol, but it uses IP and Ethernet in the network and data link layer. So basically, no acknowledgements are being issued for packets or frames, but acknowledgements are required for segments, which is reliable, which is reasonable. Why do you want to check at each and every step if every frame and every packet has arrived? They are part of a particular segment. You just evaluate at the end whether the segment has arrived correctly. So this file transfer protocol is using TCP, which will keep track of each and every segment, but it will not acknowledge each and every IP packet or a data frame. So you have all this setup of a connection acknowledgement number. This one, you can see the Ethernet. It is this one. Data has been generated. It goes to the TCP. It goes to the transport layer where TCP is being used. Okay, then it goes to the network layer where source IP and destination IP is required to send packets, and then you have this Ethernet or data link layer where Ethernet protocol is being used for sending the frames of data with destination address and source address. Again, this now you see this type field 0800. If you convert it into decimal, I think it will come 2000 something. This is a hex. This is the code for IP packet. This recognizes that previous layer protocol is using IP. Similarly, there is something called this protocol number, which we'll discuss later on when we study IP network layer, which recognizes the previous layer protocol is TCP. Okay, so we'll talk about that later on. Currently, just let's focus on this. So let's replay what's going to happen. This connection is made. Let's keep it on top. Okay, let's keep it on top. So that has been sent. Then a response has been made. Okay, there is a request to connect. A response has been made. Now file transfer will happen. It asks for this PC ask for a username. So I give it Cisco. So now this Cisco is being sent. It needs a password, so I type Cisco again. When the Cisco password has been sent, then it allows it. This FTP mode is allowed to this PC. Now I can do certain things. I can start, let's say, we had used previously what? Let's get directly. We can do dir command and all those, but let's try to directly get file transfer in progress. So let's do. So it is sending a command. I want to get this. So it responds. First segment has probably arrived. Let's see the first segment. Okay. Let's device at PC0. As you can see here, they are keeping track of all the sequence numbers and acknowledgements numbers in the TCP, transmission control protocol, in the network layer. Okay, so that finally all the segments arrive. But in this scenario, IP and Ethernet is not keeping track of any acknowledgements for particular frames or packets. The TCP layer is only keeping track of its not network transport layer. The TCP protocol is only keeping track of its different segments. So this layer, this out, it received a packet with particular sequence, so it will acknowledge it, and same it will go on. Every packet, or sorry, every segment received will be acknowledged. This is how it will continue, and so on and so forth. But this is a simulation of how, let's say, when you connect to a server, how you access various data. So some of the transmissions will be erroneous, then it will be resend, and all those things will happen. So you see, suddenly if there is some flow control needed to be done, too much data is being sent, and TCP will again intervene and do. For example, here the buffering takes place. So all these processes are shown. It's a very good way to visualize what happens when we are accessing data from servers. So I'll stop here. We'll go for then switches and local area networks. You can try using different applications what happens where. It's very good to visualize so that you will conceptually get what is happening. You can look at each and every packet that is sent, or every data packet or data frame that is sent, to understand what is happening on. So I'll stop it here. We'll go for LANs now.